Let's start with adding and subtracting decimals. Where have we seen adding and subtracting decimals before, especially in the real world? Well, that is with number problems. So for example, money problems, sorry. So for example, if we've got something like, I don't know, £2.54, add 32 pence in the real world. A lot of us can do this almost automatically because we deal with money every day. But if we're going to do that mathematically, we go, well, we've got £2.54 like that. We've got 32 pence. So let's write that like that in pounds. We've lined up the digits there and we use column addition like I'm going to look at in a minute. Anyway, we've got 4 add 2 is 6, 5 add 3 is 8, 2 add 0 is 2. So we know it's £2.86. A lot of us wouldn't need to use column addition to do that. Okay. Another example, if I was to rub that out all out, another example could be something along the lines of, if I have some money and spend some, sorry, this is taking a lot longer than I originally realised it would do. So if I've got some money and I spend some, so for example, if I've got, I don't know, £4.86, go to the shop with £4.86, and I buy some bread that's cost 32 pence. How much money have I got afterwards? Well, I'm taking that away on because I'm spending it. £4.86, take away 32 pence. Again, technically no pounds there in the 32 pence. 6 take away 2 is 4. 8 take away 3 is 5. 4 take away 0 is 4. So I've got £4.54 left at the end. I've already touched on this already, but adding decimals, if we haven't got money, if we've not got a contextualized example, we use addition column method like we would do with integers. Remember, integer is a whole number, not a decimal. So for example, if I had 162, let's take decimals out, and I wanted to add 384, I would use column addition, which we've seen before. With this example here, I've got 1.62 and 3.84. Let's think about what those mean. I've got 1 wholes, 1 units, 6 tenths and 2 hundredths. I've got 3 units, 8 tenths and 4 100ths. So that's why I've got to line the hundredths up. I've got to line the tenths up and the units up. Let's add them together. 2 add 4 tenths is 6 tenths. 2 hundredths add 4 hundredths is 6 hundredths. 6 tenths add 8 tenths is 14 tenths. So that's kind of like writing 1.4, isn't it? That's why I write the 4 there and carry the 1. 1 unit, add 3 units of another unit, that's 5. So my final answer is 5.46. 5.46. The next one, I've got 6.43. Similar idea than the last one. Units, tenths, hundredths. I'm going to line them all up. 0.62 and 0.05, and I'm going to then add them together like before. 3 add 2 add 5 is 10. 4 add 6 add 1 is the 11. And 6 add 1 is 7. So the final answer is 7.10. Okay, so subtracting decimals is exactly the same as if we were subtracting integers, except we've got a decimal point here. Now remember, we need to line up the digits. So for example, the units need to line up, the tenths need to line up, the hundredths need to line up, and so on. So we've got 4.94, we've got 4 units, 9 tenths and 4 hundredths. Take away 2.67, 2 units, 6 tenths, 7 hundredths. 4 hundredths take away 7 hundredths. We can't do. Well, we can, it becomes negative. So what we need to do is we take a tenth off here and replace, so the 9 tenths become 8 tenths. So I'm taking a tenth off that and I'm adding the tenth onto here. The reason it becomes 14 then is because I'm essentially adding a tenth onto the 4 hundredths to make it possible to take away that 6 tenths. So 1 tenth add 4 hundredths, so that's the same as doing 10 over 100 times the first fraction by 10, add the 4 hundredths, Okay, that gives me 14 hundredths. So I've now essentially got here 14 hundredths take away 7 hundredths, which is 7 hundredths. That's why the 7 is in the hundredths column. 8 tenths take away 6 tenths makes us positive 2 tenths. No borrowing needed there. 4 units take away 2 units, or 4 whole numbers take away 2 whole numbers, is 2 left over. We don't need to borrow there. Job done there. I thought I'd include the fractions there just to help you understand what's going on there a little bit better. Over here, what I could do is I could line them up like this, okay, and so on. I could line them up like that. Now, the issue with that is it gets a little bit messy. I will show you why now. Let me just rub it all out. I will show you why it gets a little bit messy. So, for example, if I had a little bit of an easier one, let's go for 2.4 take away 0.8 take away 0.6. 2.4 take away 0.8 take away 0.6. Okay, 4 take away 8 we can't do, so we borrow it from here and put it there. 14 take away 8, okay, is 6. But we've got to remember I've got 6 up to this point. If you don't remember you've got 6 up to this point, you're then going to want to do 8 take away 6. It's not true. Up to this point I had 6. Okay, so what we really must do, instead of doing column, I'll rub all this out because that's not to do with the example we've got at the top. That was just a side example. Rub that out. What we must do first is add these together first. Because if I add these together first, then I can take them both away from 10.63. Because if I'm doing 10.63, take away one value, take away another value, that's the same as the 2 original values I'm taking away added first, then taken away altogether. Okay, and let's think of an example, real world example. If I do £10, take away £4, take away £3, yes, I can do 10 take away 4 is £6, take away another £3 is £3. Or I could do, this is 4 add the 3 is a £7, 10 take away £7 is £3, okay, because I spend £7 altogether. Okay, it's good to relate it back to money sometimes to understand what we're doing. So let's add those two together. First, I'm not going to do adding because I've done it on the last slides. I'm just going to tell you the answer for those two added together is 7.71. So what I'm going to do then is I'm going to do 10.63 take away 7.71. Then I'm going to use column like I did over there. I'm not going to go through all the language and why I'm doing each individual step. I'll just do it very quickly. 3 take away 1 is 2. I can't borrow from there, so I put a 10 there. I cross that out and put a 9. Borrow it to there. 16 take away 7 is, do I know what that is? I should do 9. 9 take away 7 is 2, and a 0 there. So the final answer is 2.92. Final answer. Okay, so it's really important that we can convert between fractions, decimals, and percentages because it relates and it means you can access a lot more areas of math. So, for example, if I've got something like 70%, it's really important you know the equivalents as fractions and the equivalents as decimals. Now, to convert 70% to a fraction, we know that any percentage is out of 100%. So if you've got 100% of the test, that will be the total always amount of marks. So when we draw it as a bar or draw it as a diagram, we always have 100% as the whole thing. So we know then that's the same as 70 out of 100, okay? Which I could simplify to 7 out of 10. So 70% as a fraction is 7 out of 10. There's a few ways to think about decimals. I'm going to go about it doing it this way. 100% as a number, remember percentage is proportion, so 100% is the whole thing, 70% is 7/10 of the thing. So 100% as a number, as a value, would be 1. So for example, 70% then would be 0.7, and in this way we can see that we divide by 100 to get from the percentage to the decimal. So 70% is the same as 7/10, which is the same as 0.7. I'm going to do a different example over here. I'm going to start off with a fraction this time. So let's say something like 3/10. Well, 3/10. Let's think about what it would be out of 100. You always want it out of 100. Multiply by 10 to find the equivalent fraction, which is 30 out of 100. 30% out of 100%. It's 30%, isn't it? As a decimal, well, we've just seen what if 100% is 1. 100% is 1, then 30% is 0.3 out of 1. I guess you could think about it as well. So 3 out of 10 is the same as 30%, is the same as 0.3. You'll be asked to convert a variety of things. So for example, let me just get purple back again. For example, 2/5. You could be asked to convert. You could be asked to convert 15%. You could be asked to convert 0.03. Let's have a look at them all. Well, 2 out of 5, we want it out of 100, remember, it's always out of 100%. Times by 20, multiply by 20 to find the equivalent fraction. And remember, if I had a bar split it up into 5 and shaded 2 regions, that'd be the same as drawing a bar, same length, with 100 sections and shading 40 of them. They are the same fraction, they are equivalent. Well, that's 40% out of 100%, that's 40%. How to convert a percentage to a decimal? Divide by 100, 0.4, remembering that 100% is just 1, the integer 1. 15%, well 15% is out of 100%, so it's 15 out of 100. I could simplify by dividing by 5 if I wanted to, which is 3 out of 20. Remember to convert to a decimal, we divide by 100, which is 0.15. Let's look at the decimal. Well, if we divided by 100 to get to the decimal up here, that means I'm going to times by 100 to get to the percentage, aren't I? I'm doing the opposite thing. That gives me 3. 3%, well 3% is always out of 100%, 3 out of 100. I know I can't simplify that. Why? Because that's a prime number, really important relating it to other areas of maths. That's a prime number, which means I can't simplify, so we've finished. So 0.3 is 3%, is 3 out of 100. Visualizing the fractions, decimals and percentages in shapes is really important. I'm going to use bars because bars can be transferred to loads of different areas of maths. You can use it in ratio. We can use it doing percentages. We can use it when we're looking at proportions and things. So here I've split my thing up into 10. So let's say this is 100%. Remember my original bars always 100%. That means each of these must be 10%, mustn't they? Because I've got 10 tens and 100. These are all 10%. These are all meant to be say percent next to them, just so you don't get confused. That's not the value, that's the percentage. Okay, so the whole thing is 100%. So for example, if I was to shade in 4 of those, well that's 40% because there's 4 tens, that's 40%. Okay, and can you see how if I wrote that as a fraction, that's 4/10 or 40 out of 100? Or I could simplify that to 2/5. That's 2/5 of the bar I've shaded there. As a decimal, if I wanted to, I could write it as 0.4. Okay. Another example. If I shaded just 1, 2, and then that's meant to be a half there. Sorry, that's a really, really bad half. If I shaded 2.5, well, that's 2.5 lots of 10, 10, 20, and half 10 is 5. So that's 25%. So the purple bit is 25%. Well, 25% we know, 25 out of 100 simplifies to 1/4. So 25% is the proportion of something that you've got there, which is a quarter in this case. The 40%, whenever you see percent, it's a proportion of what you've got. So for example, if I knew a test was out of 150 marks, if I got 100%, that is 150 marks. The 150 marks is the value. One more example at the bottom. What have I shaded there? That's 1 out of 4. Okay. Well, a quarter, I know, is 25 out of 100 if I multiply the whole thing by 25, which is 25%, which we know as a decimal is 0.25. Okay, it's really important that we also know how to convert a fraction or a decimal percentage when the original fraction is not a factor of 100. So for example, if I had, let's go for an eighth. Okay, when we later on for exams, in Key Stage 4, we're going to have to remember, in years 10, 11, it's something we're going to have to remember what the decimal percentage is. For now, we're not going to. So for this one, I was talking about earlier, well, can't we just find out how many 8s fit into 100 and multiply it? Well, we can't, because 8 doesn't fit into 100 exactly, unless you've got a calculator and you can multiply it by a decimal. So in this case, what we can do is, I'm going to put a little sad face because I can't really do that. Well, I could, but it'd be a little bit tricky. So what I'm going to do is I'm going to think about what 1 split up into 8 means. Or 1 split up into 8 is the same as 1 divided by 8, isn't it? And 1 divided by 8, we could use a calculator, or we could use our good old-fashioned bus stop method. 1 divided by 8. 1 is what we're dividing into, 8 is what we're dividing by, so it goes on the outside of the bus stop. How many 8s are in 1? Doesn't fit, we carry the 1. How many 8s are in 10? 1, remainder 2. How many 8s are in 20? 2, remainder 4. And how many 8s are in 45? So the final answer is 0.125. Okay, I'm going to just go through rounding now as quickly as possible without trying not to miss out any key information. 12 to the nearest 100, well, sorry, 12 to the nearest 10. We need to think about what to the nearest 10 means. All that means is we want to round a number, so move a number almost, so that it's closest to the number that it's, the 10, sorry, that it's closest to. So for example, 0, 10, 20, 30, 40, 50, 60, and so on. Okay, so I need to think about which 10, one of these, is 12 nearest to. Well, I could draw a diagram if you find it hard to visualize. It's between 10 and 20. They're my two 10s, it's between. It's here. So that means it rounds down to 10. That's the nearest 10. This one over here, I want to the nearest 100. So I want to the nearest, I'm going to do it in red. I want to the nearest one of these. So I need to think about, right, which of these hundreds is it nearest to? Okay, these are my hundreds, aren't they? Okay, which one is it nearest to? Well, again, if you find it hard to visualize, I know 264 is between 200 and 300 because I've got 200s here. Okay, well, 250 is in the middle, so that's 250. Well, 264 then is this one here. Well, look what it's closest to. It's closest to 300. So it rounds up to 300. And the bottom one I'll change to a different colour, we'll do green. It's the nearest 1,000. Again, we want it to the nearest 0, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, whichever one of them is closest to. Well, 3,000, there's your thousands, is between 3,000 and 4,000. Okay, well there's 3,500, but it's 3,412, which is about here. 3,412, and that rounds down to 3,000. So the answer for that one is 3,000. So let's look at rounding to the nearest whole number or integer. So for the first one, 14.6. Again, we know whole numbers are, I could do negatives, but I'm just going to look at positives. So now 0, 1, 2, 3, 4, 5, 6, so on, so on. They're all whole numbers, they're our integers, or our 1 times tables, if you like, multiples of 1. So 14.6, the nearest whole number. We want the number that 14.6 is closest to from this list. Well, let's think about it as a diagram if you can't visualize it. 14.6 is between 14 and 15. 14.5 is in the middle, so 14.6 is about there. Well, that's closest to 15. So that means it rounds the nearest whole number to 15. 0.97 is integer. Integer again is whole number. Let's visualize it. 0.97 is between 0 and 1. 0.97, very close to 1. That means it rounds up to 1. Just very quickly, if it was 0.5, that would round up to 1. So if it's 0.5, it rounds up to 1. Same for the last slide. If it's 55, it rounds up to 60. If it's 650, it rounds up to 700. Okay, so significant figures are non-zero digits. So if it says the first significant figure to one significant figure, you look at the first non-zero number. So the first non-zero number is 100. So this is just the same as rounding to the nearest 100. Well, 132 rounded to the nearest 100 132 rounded to the nearest 100 is 100. What's the second significant figure in here? That's that one. That is also 100. We're rounding 1,800 to the nearest the second significant figure. So 1,800, 1,900 to the nearest 100. There's 1,843. It rounds down to 1,800 or 1,800. To three significant figures, let's count the first three non-zero digits. 1, 2, 3 is that one, which is my 10th. So I'm rounding to the nearest 10th, which is the same as rounding to one decimal place. 93.2 145, or 93.2, 93.3, 93.2 145 is down here to 145, because this here would be 93.25, rounds down to 93.2. We look at the 4. If that's less than 5, we keep it the same, so 0.86. And if it's bigger than 5, say it was 0.8673, we'd round it up to 0.87. Estimation. Remember, estimation in the real world is just like a bit of a guess. It's a good guess, though. It's an educated guess. So what we do is we round all the numbers that we've got to a suitable degree of accuracy. So for the first one, let's round them all to the nearest 100. Usually we round to one significant figure, which in this case is to the nearest 100. But sometimes we do it more cleverly than that. But let's keep it to one significant figure for now. So 578 rounds up to 600. 720 rounds to 700, so a estimate for that would be 1300. I'm not going to put equals there. I'm going to put an arrow because they're not equal, are they? But they're going to put an arrow to say we've estimated that. I'm going to put an E above the arrow to show I've estimated it. Same over here. 2 times 7, well that's 14, so a good estimate's 14. And for this one down here, 7, 1.14 rounds 7, 16.88 rounds 17. 10, 11, sorry, and 5. Okay, I'm going to carry on with this and see what happens. So 7 out of 17 is 24. 11 plus 5 is 16. It's 24 out of 16. Simplify that, dividing by 4 gives me 6 over 4, which is 3 over 2. Sorry, divided by 8, which is 1.5. So a good estimate would be 1.5. Now, what we could have done, I love that. What we could have done, which is what a lot of teachers say to do, is round them to one significant figure. It's not as good of estimate, but it's an easier one to calculate. So instead of 1.5, that's a good estimate, and that would have got you the full marks. Here, 7.14 rounds to 7, as it does before. To one significant figure, 16.88 actually rounds to 20. 10.96 rounds to 11. Sorry, 10, my bad, 10. And 4.85 rounds to 5. So I'm actually doing 27 over 15. That is another estimate. Again, if I divide by 3, I get 9 out of 5. 9/5 is 1.6. That's a different estimate to the one I got before. It's actually not as good of an estimate because I rounded this number, and I rounded this number to a better, more accurate estimate, but they are both correct. Let's look at estimation and worded problems. So in the cinema, there are 28 rows, and in each row there are 22 seats. So if I was to draw a bit of a diagram of this cinema, not necessarily knowing it's rectangular, but in this case we're assuming so because it doesn't tell us any different. We've got 28 rows and we've got 22 seats going that way. Each one costs £8.20. Work out an estimate. Well, let's work out how many seats we've got. So if we've got 28 going up, we've got 22 going across. That means we've got 28 times 22 seats. But it says estimate. So whenever it says estimate, circle it, which means we must be rounding. Okay, we're guessing, a smart guess. 28 rounds to 30, 22 rounds to 20. That means we've roughly got 600 seats. We haven't. We've got 28 times 22 seats, but it's only an estimate. Each ticket costs £8.10. Let's round that 8 to £8. 600 seats at £8 each. That is £4,800 as an estimate.